Hi, everyone. Today's lesson is a review for conics section that we're going to cover circles, ellipses, hyperbolas, parabolas, and systems of non-linear equations. So this is my last minute Lucy review, so I hope this helps you. Getting started, let's start with a warm-up. And we're going to write the equation of the ellipse that has a major axis of length 16. So if it has a major axis of length 16, okay, that means that we went to the right or to the left or up or down 8 both ways. If my focal points are at -5, 0, so there's one point right here at -5, 0, and my other focal point is right here at 5, 0. What this means is that because my focus points are on the x-axis, that means that my major axis is the x-axis. Additionally, because these are both 5 units apart, that means that my center is going to be at 0, 0. My length of my major axis is 16, which means that the distance to the right is 8. So this means from here to here is 8. So we're going to put a point right here. And that's my vertex, and my vertex is at 8, 0. And then this point here on the left-hand side, also 8. 8 distance from here to here, and then also 8. And so this would be -8, 0. So in an ellipse, you know that the larger axis, or your a squared term, is your x-axis. So that means that my equation, which is at 0, 0, we could start it off like this: x minus 0 quantity squared plus y minus 0 quantity squared equals 1. And then underneath these values here are my a squared and my b squared. Because my focal points are on my x-axis, that also means that 8 going to the left and right, so that's going to be 64 because that's a squared. So if 8 is equal to a, okay, then a squared is 64, and that has to go underneath the x-axis. Now we also know that c is equal to 5 because this distance from here to here is my c distance, and that's 5. So I can use the formula that we have for ellipses, which is c squared is equal to a squared minus b squared. For ellipses, a is always greater than b. So we're going to say 25 is equal to a squared, which is 64, minus b squared, which we don't know. So we're going to subtract 64 from the other side. So what I'm going to do is I'm going to go, well, 25 minus 64. Okay, we're going to subtract, borrow 5, 4, 3, and that's a 9. This means this is negative 39 is equal to -b squared. So b squared is equal to 39. So that means up here is 39. So this is technically the equation of my ellipse in standard form. I could rewrite it like this so I don't have the 0 in there. So it just look like this: x squared over 64 plus y squared over 39 is equal to 1. And remember, ellipses have both x squared and y squared terms are positive. So reviewing circles, what we know about circles is we have a circle. Let's say we have a graph of a circle, which I don't think you can see that. So let's say my graph on my circle was right here. On the origin is my 0, 0. That means that this is my radius here. And then that distance r is all the way around, right? That distance all the way around. So technically, it would be an ellipse if one of these lengths was a little bit longer. That would mean also that it wouldn't be a circle too. So for a circle that has a center at 0, 0, you're just going to have x squared plus y squared is equal to my radius squared. However, if I move my center off and I had another radius, let's say it's 3 all the way around, my circle would then look like this, but it would be off of the center. And we could call that hk. So x minus h quantity squared plus y minus k quantity squared is equal to my radius squared. Okay? Now for an ellipse, what you do need to know about an ellipse are a few things. Number one, you know that you've got an x and y-axis, and you know that you've got vertices. Vertices are always on the major axis. So let's say this is my major axis right here, this length here. That means that would be one of my vertices. That would be one of my vertices here and here. Additionally, these would be my co-vertices, and we also call those endpoints. If my major axis is on the x-axis, that means that my x coordinate, this value here, this a squared term is positive. And also the y squared term is positive, but it also means that this value here, this a squared term, a is greater than b. It has to be bigger. Whereas my major axis, if it was on the y-axis, is going to be underneath the y. See how the y now has the a? Okay, so that means that a is always going to be on the larger axis, okay? Additionally, for my focal points, I'm going to say that c squared is equal to a squared minus b squared, whereas if you had a hyperbola, it would be a squared plus b squared. So major axis, minor axis, the major axis is going to be 2 times a. Remember, a is always going to be on the larger axis, and the minor axis will be 2b. My vertices for an ellipse are always the endpoints here and here. Those are always the endpoints. For a hyperbola, though, a hyperbola is a little bit different in that hyperbola is going to have, it's like a slice of a cone that goes this way. Hyperbola is going to have one negative term. So the x squared term is either going to be negative, okay, which means that that's b. Okay, because the a squared term, unlike an ellipse, the a squared term doesn't have to be bigger than the y squared term, the b squared term. It doesn't have to be bigger. But the a squared term always goes with the positive axis. So we would say a squared is here. And if this was the case, my hyperbola would do this. Whereas if my y squared term was negative, so if I had x squared over a squared minus y squared over b squared, this would equal 1. Also, we have foci. My focal points would be c squared is equal to a squared plus b squared. And that's how I would find those values. Remember, the focal points are always in the arc. It's in the middle of that arc right there. It's in the middle right there. You also know that you have asymptotes. The equation for the asymptotes when the center is 0, 0 is going to be y is equal to plus or minus the square root of well, depending on where I'm going, it's always y over x. So I know, see the a and the b change. See with this, I always just think, okay, well, it's got to be my rise over my run, but don't forget the x there. So if I had, let's say, x squared over, let's say, 25 minus y squared over 9 equals 1. A does not mean it's the bigger number. A is always your rise. It's always your rise over your run. So you've got y is equal to plus or minus the square root of that, which is 3, over 5, and then x. So that would be the equation of my asymptotes from the center that I have. If I move my center, then this will change. And I'll show you how to do that later. But if my center change, well, I guess I could show you right now. If my center changes, so let's say if I had x minus 2, quantity squared, over 25, minus the quantity y plus 3 squared over 9 equals 1. Then the equation of my asymptotes would change. And so I would put those values in for y and x. So what I would have is, I would have y minus 3. See, y minus 3 is equal to plus or minus 3/5 times the quantity, plus or minus 3/5, and then x. Where's my x? 2. So it'd be x plus 2. And so this is just an equation. This is not squared because this is an equation of a line. This right here is the equation of my hyperbola. But this line right here, which I drew right here, okay, that line, that's the equation of my asymptotes because they moved off of the axis, okay? So anyway, we'll do some examples like that. So then we met Mr. Parabola, and we went from ellipse to parabola. And so parabolas were kind of interesting because parabolas also had a vertex, that's my vertex right there, a vertex point, but they also had a focus point, just like a hyperbola and an ellipse. But additionally, they had something extra, and that was called the directrix. Okay. You also had this length right here. We call that that length right there, we call that either the focal width or we call it the latus rectum. I know it's a strange word, but that's the way we call it. It's a Greek term. So we also know that the distance from my focus to my vertex, see this being my vertex, is going to be the length of P. it means that the distance from here to here is also p. But the distance of my focal width or lattice rectum, this distance right here, is actually 4p, okay? All right, so in an equation for a parabola, what we learned was that you had two ways of writing the equation. If you could see this, that's great. What that shows you is this. 4p times the quantity y minus k is equal to x minus h quantity squared. Now, a lot of people write their equations like this, and this is completely fine. I personally prefer my squared terms on the right and also this 4p. I want my y term or my x term, if it's not squared, I want it by itself. So this is going to be y minus k equals, I'm going to divide out the 4p. So 1 over 4p times the quantity x minus h squared. It also means that, remember what I said p was, this length right here is the distance from my vertex to my focus. So depending what that is, let's say it was 3. Let's say that distance was 3 units. I would go 1 over 4 times 3, which would be 1 over 12. You also need to understand that there's 4 different ways you can set up your equation. You can set up your equation like this, y equals x squared, which means my parabola will look something like that. You can set it up like this, where it's y equals negative x squared, where my parabola will be upside down like that. You can set it up as x equals y squared, where my parabola will be sideways. Or you can set it up as x equals negative y squared, which means my parabola will be this way. So any one of those ways is you have to look at the graph, and you're going to distinguish this graph between an ellipse and a hyperbola, because parabolas only have one squared term and ellipses and hyperbolas have 2. So this is telling me, hey, this is a parabola. My vertex is at 5, negative 2. So we're going to go over 5, there's 5, down 2. So that point here is my vertex. They told me that. And that's going to be 5, negative 2. It tells me that my directrix is at y equals negative 5, which means that if it's y equals, it crosses the y-axis. This being the y-axis, it has to cross that. So we know that this is negative 2, so we're going to go down to negative 5, okay? And we're going to draw in our line y equals negative 5. It means that this is my directrix. It means that this distance here is p, which means that p is equal to 3. It also means that because that's my vertex and this is my directrix, that my parabola is going to scoot up like that, okay? And it also means that my focus point is going to be in the middle 3 units up. So if I went down 3, that means I have to go up 2 more plus that 1 right there, which means that my focus point is going to be at 5, 1. So what they're asking me to do right here is they're asking me to write the equation. That's it. So I know that my vertex is 5, negative 2. I know it's a parabola. The parabola is going to look like this eventually at y equals x squared. So we're going to go y minus k equals 1 over 4p times the quantity x minus h quantity squared. So therefore, I'm going to put my vertex in, and I've got 5, 2. So y minus or plus 2. Remember, this goes with x, this goes with y. Just because y is first over here doesn't mean you put the 5 first. So y plus 2 equals 1 over 4p. P is 3. And then times the quantity x minus 5 quantity squared. So my final equation of my graph is going to be y plus 2 equals 1 over 12 times the quantity x minus 5 quantity squared. And so you are completely welcome to leave this equation like this. Just note that those of you who like the equation with the 12 over here, you also can write the 12 like this. Y plus 2 is equal to x minus 5 quantity squared. Either one is completely fine. This question says, find the equation of the parabola that has a focus at negative 3, 4. So let me see here. Negative 1, 2, 3, 1, 2, 3, 4. So here's negative 3, 4. It's a focus. So I like to put the F there to remind me it's a focus point. I also know it's a parabola. And a directrix of x equals 7. So that means at 7, and it's got to go, it's x equals, so it's going through my x-axis. So here's x equals 7 right there. All right. And so what that tells me is this. My vertex is halfway in between this. So if I went over 3 and I went to the right 7, that means that total length is 10. Okay, which means that halfway in between is 5. So I'm going to go over 3, 4, 5. Okay, where am I? I am at 2, 4. So at 2, 4, that's my vertex, which means that my graph is going to do this. Remember, the focus point is always inside that arc. So writing the equation, it's a sideways graph. So we know it's not a y equals graph. It's going to be an x equals negative y squared because it goes to the left, which means that, see this term right here, that value is going to be negative. Don't forget that because it is going opening to the left. So my vertex is 2, 4. Remember, this 2 goes with x and the 4 goes with y. So it's going to be x minus 2 is equal to negative 1 over 4p times the quantity x minus, oh, hold on a second. I messed up on that. Thank you. X minus 2. Oh, hold on. Dun, 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 dun. Y minus 4 quantity squared. So I know that the distance of P is this distance from here to here. We already know, we talked about this. This distance is 10, which means this distance is 5. So P is 5. So that's going to go right there. So we're going to go x minus 2 is equal to negative 1 over 20 times the quantity y minus 4 quantity squared. And just again, if I wanted to rewrite that, I could put that 20 over to the side if I wanted to. That's up to you. Determine the conic and write it in standard form. So this conic, because it's got a positive x squared and a positive y squared, is an ellipse. All right. Because it's an ellipse, I am going to try to complete the square. So we've got an x squared plus an x. We have a y squared and a y. That tells me that I'm going to complete the square 2 different times. So let me group first. So we have an x squared plus 6x, let's see, plus 4y squared minus 8y is equal to negative 9. So completing the square, x squared plus 6x, half of 6 is 3, 3 squared is 9, plus I'm temporarily going to factor out that 4 and put it in later. So 4 times y squared minus 2y, half of negative 2 is negative 1. Square that is 1. And then what I'm going to add to this right side, I have negative 9, is what I added on the left. So see how I added this plus 9? So that goes there. And see how I added this 4 times 1? Even though I temporarily pulled that out, I have to put that back in. So this is going to be plus 4. And so what it looks like to me, factoring and everything, is x plus 3 quantity squared plus 4 times the quantity y minus 1 quantity squared is equal to 4. I'm going to divide, for this to be in standard form, this term has to be 1. So that means I need to divide everything by 4. And I'm going to have x minus 3 quantity squared over 4 plus y minus 1 quantity squared over 1 is equal to 1. So now this is standard form. It shows me that, writing the components, it shows me that my center is positive 3, positive 1. And therefore, I'm going to draw my graph. I'm going to try to make this a little bit bigger. Okay, so it shows that my graph is 3, 1. So let's see, over 3, 1, 2, 3, up 1. There's my center. In the x direction, look under x. In the x direction, see that number 4? You're going to go to the left and to the right for the square root of 4. So whatever's underneath the x value, that's x. You're going to go the square root of that. So you're going to go the square root of 2. You're going to go 2 left, 2 right. Under y, I'm going to go up 1, down 1, because the square root of 1 is 1. And then I'm going to connect those points. And so therefore, we know this is an ellipse, and so I'm going to connect my points, and that's my ellipse. I also need to know what my major axis is. So my major axis is going to be 2a. Now remember, in an ellipse, the higher number is your square number. So that's your a. This number here is my b squared. So that means 2 times a, so that's going to be 2 times 2, which is 4. And for my minor axis, that's going to be 2b, which is going to be 2 times 1, which is 2. I mean, just to be clear, I can count 2 on both sides across, 1, 2, 3, 4, and count my major axis, and then figure out what a is after that too. Also, same with b. The only thing we have left to do is to find the focal points, or the foci. And the foci first are at c squared equals a squared minus b squared. So c squared equals my a squared 4 minus 1. So c equals plus or minus the square root of 3. So that means that I'm going to go to the right 3 and to the left, not all the way. Hold on. I'm going to go to the right, the square root of 3, and to the left, the square root of 3. So that value right there is not at my vertex. It's close to it, but it's not at it. Where it is what you're going to have to write. So if my center is at +3, +1, then where my focal points are, +3, +1, my focal points are going to be parenthesis 3. If they're on the x-axis, you add this foci distance to your x-coordinate. So that's going to be 3 plus the square root of 3 will be this one. So 3 plus or minus the square root of 3, comma 1. And that's where my focal points are. And let me lift that up just in case. Okay, determine the conic and write it in standard form. So because I have only one squared term, this is a parabola. And what that means is, this being a parabola, it means that I have a directrix, I have a focus point, etc. And in order to find that, I'm going to have to complete the square possibly. So what I'm going to do is move everything. I'm going to move my squared term to my right, and I'm going to move everything else to the left. Okay, and first I'm going to move this 9 over. So I have x squared plus 9 is equal to 2y plus 6x. Okay, that's not very helpful. I need to move the 6 over also. So x squared minus 6x is equal to 2y. Let's see, I'm bringing that 9 back over. And so now I have my x squared terms together, and I can complete the square. I only am completing the square one time because, remember, it's a parabola, and you only have an x squared term and an x. So before I complete the square, I'm just going to put that squared term on the right like I like that. And let's go. Half of 6 is 3. 3 squared is 9. I'm going to add 9 to there, and I'm going to add 9 on the left. So now what I have is 2y equals the quantity x minus 3 squared. So I could write it like this. 2 times the quantity y minus 0 equals x minus 3 quantity squared. I could even write it like this. Y minus 0 equals 1/2 times x minus 3 quantity squared. And I like that because my vertex, first of all, is going to be 3, 0. So I'm going to put my value in for my vertex right here, v, for 3, 0. Also, I know that, remember this point right here, this value, that's a, right? So for that, a is equal to 1 over 4p. Well, that means 1/2 equals. 1/2 equals 1 over 4p. I'm going to cross multiply. I get 4p equals 2. So p equals 2 over 4, which is 1/2. It means that the distance between my vertex and my focal point and my directrix and my vertex is 1/2. This is a y equals x squared graph, which means it's going to be a positive graph like this, right? Okay. It also means that this distance going up from here, this value being 3, that point up here is my focus point, and that value is going to be over 3, comma, up 1/2. And it also means that down here, I'm going to have a directrix, and that's going to be y equals negative 1/2. All right, this conic, positive is another ellipse. It is already being completed, the square, so not my vertex, but my center for this graph. My center is -2, -2. Let's see, graphing this up here. Let's put this here. All right, I think it's really important that you graph everything. You can see so much better. So here we go at -2. This is my center at -2, -2. All right, -2. That's -2. In the x direction, you're going to go the square root of 9, which is 3. So I'm going to go 3 to the right, 1, 1, 2, 3. And then I'm going to go 3 to the left, 1, 2, 3. And then I'm going to go up 2. So up 2 and then down 2. So my ellipse is going to look like this. Okay. All right. So what's happening is I have a couple of things that I need to talk about. I need to know where my focal points are. Remember, my focal points are always on my major axis. My major axis is 3 to the left, 3 to the right, which means that's a total of 6. So my major axis is equal to 6. My minor axis is going to equal 4 because it's going to be 2b. Remember, if b is equal to the smaller number, that's b squared. So b is 2. So we're going to go up 2, down 2. So that's my minor axis. My focal points are at c squared equals a squared minus b squared. So c equals plus or minus the square root of 5. So that means I'm going to go square root of 5 to the right and square root of 5 to the left on my major axis. If I were to go up or down this way, my focal points would have been outside of my ellipse, and therefore I would have known that that wouldn't be my major axis. So let's see. So we know that's the square root of 5. My center at -2 and 2, -2, -2, I need to add this focal point here to this in order to figure out exactly where these points are, right? Like right there. So because it's on the x-axis, you're going to add this number here to the x coordinate. So it'll be -2 plus the square root of 5, comma, -2, and this focal point here will be -2 minus the square root of 5, comma, -2. Okay. So the next problem says determine the conic and write it in standard form. Write its components. So what I see is an x squared and a y squared. I see a minus sign, which tells me that this conic is a hyperbola. All right, so what that means is I'm going to group my x's and my y's to see if I need to complete the square. So we have 4x squared plus 8x. We have a minus 3y squared and then equal to -16. And so what this is going to do for us right here, hold on, let me fix that, is it's telling me that because I have a y squared but no y, I'm not completing the square there. I have an x squared term and an x. So we're going to go 4 times the quantity x squared. I'm factoring out just the numbers. You never factor out the letters when you're completing this square. Plus 2x. Half of 2 is 1. 1 squared is 1. Minus 3y squared is equal to -16. Now remember, we temporarily factored out that 4. We need to put that back in so we know what to add to the right-hand side. So that's going to be plus 4. So we're going to simplify. We get 4 times the quantity x plus 1, quantity squared, minus 3y squared is equal to -16 plus 4, which is -12. We're going to divide everything by -12. And in doing that, it's a little bit tricky because what that just did by dividing by a negative number is it changed the sign. Where previously I had a -y squared and now it's a -x squared. So what I have is an x plus 1 quantity squared over 3. And remember, this is a negative, so that's out front. Plus y squared over 4 is equal to 1. So we have this equation right here. Now, this also tells me that my hyperbola has a center of -1, 0. It means in the x direction, I'm going to go the square root of 3. Okay, so I'm going to move that up here. Let me try to make this a little bigger. Okay, so we have my equation. Oops. There we go. So -1, 0 here. Okay, in the x direction, we're going to go the square root of 3, which is around here. In the y direction, we're going to go the square root of 4, which is about here. And then remember, because this is a hyperbola, we are not connecting those dots. We are going to make a little box like this, okay? And then we're going to put in our asymptotes like that, okay? And we're going to look at this and go, okay, wait a minute. Which one of these, x squared or y squared, which one is positive? Because my y squared term is positive, that means that right here, my graph, my vertex, it's going to go up and follow the asymptotes. From here, it's going to go down and follow both of the asymptotes. Okay, so let's see. We also have focal points. And so we have c squared is equal to a squared plus b squared. So c squared is going to equal, a squared is the positive, so 4 plus 3. So c equals plus or minus the square root of 7. That means that my focal points are going to be up here and down here. Exactly where they are, you are going to need to know. And so because it's on the y-axis, you're going to add this plus or minus 7 to the y coordinate of your vertex. So, or of your center. So if my center is at -1, 0, I'm going to add these points here to that. So it'll be -1, 0, plus or minus the square root of 7. So that's where my focal points will be. Now, lastly, you do need to know where your asymptotes are. Now, remember what I said. It's always going to be the rise over the run. So we are going to start off writing our asymptotes like this. Plus or minus the square root of the rise over the run. So plus or minus, let's see here, 4 over 3, okay, x. But remember, our center is not technically at the 0, 0, where this would be, y minus 0, x minus 0, but it is at -1, 0. So x being -1. So my equation of my asymptotes is going to be y equals plus or minus the square root of 4 over 3, parenthesis, x plus 1. And so that, and by the way, that is not squared. Remember, this is a line. These are lines. So we're going to go, it's technically from the center, you're going up 2 over the square root of 3. Then you're going up to left 3. You're going down 2 to the right 3, and you're going down 2 to the left 3. And so basically, that's what I'm talking about. Up 2 over the square root of 3. Up 2 to the left square root of 3. A couple more terms. This is my vertex. These are my vertices, okay? 2 vertices. What that means is that the line that connects those 2 vertices right there, and it's always on a hyperbola, it has to connect the vertices. We call that the transverse axis, okay? So that's the transverse axis. The other axis that just kind of hangs out there but isn't really connected to anything is the conjugate axis, okay? That's conjugate axis. Let's see. We did our asymptotes, conjugate axis, and then you do need to know where your vertices are. Those are the ones that connect, that hold the 2 parabolas, which are my hyperbolas, that hold those hyperbolas in place. So name the conic. We have an x squared. We have a y squared. They're both positive. I have a number in front here, but not here. It's an ellipse. We're going to put this in standard form, which means there needs to be a 1 right there. So we're going to divide through by 36. Everything divides through by 36. We're going to get the quantity x minus 1 all over 4 plus y plus 3 squared over 36 is equal to 1. This is the equation of my ellipse. My center is going to be at 1, -3. I'm going to graph this over here. Let's make this bigger. And so what we have here is, let's see, 1 over 1 up 3. And so that's my center. In the x direction, I'm going to go 2. In the y direction, I'm going to go 6. And this is an ellipse, so I am going to connect the dots. Remember, if it wasn't an ellipse, I would make that into a square or rectangle, all right, a box. we know that the major axis is going to be 12. And we know that the minor axis is going to be 2 times the square root of that. So that's going to be 4. We know that the focal points, our foci, are going to be at c squared equals a squared minus b squared. So 36 minus 4. So they're going to be at 36 minus 4, which is the square root of 32, which is 16 times 2. So that's plus or minus 4 root 2. And so from my center is at 1, negative 3. My focal points, remember, are in an ellipse, are always on the major axis. So my focal points, so right here and right there, are going to be parentheses. It's on the y-axis, so it's going to be added to the y-coordinate. So it's going to be parentheses 1, negative 3 plus or minus 4 root 2. Okay. Write the equation of the parabola that has a focus point at 0, 4. It's a parabola. So 0, 4, 1, 2, 3, 4. And a directrix, so that's my focus, put an F there. And a directrix of y equals negative 4, my directrix. So that's down here. So that means y equals negative 4 here, positive 4 here. So that means that the distance between my vertex and my focus point is the same distance between my vertex and my directrix. So those are both 4. So that means P is equal to 4. It also means that for my parabola, it does look like this. Okay. Because it's up like that, it's a y equals x squared graph. So we're going to go y minus 0 equals 1 over 4p times x minus 0 quantity squared. We know p is 4, so this will be y equals 1 over 20 x squared. And that's the equation of my parabola. Remember, you can also write it like this: 20y is equal to x squared. And that's completely fine also. The next question right here says determine the conic. Write it in standard form. Determine the conic. This looks like a hyperbola because see the negative sign right here. So what that means is to put this in standard form, this needs to be 1. So I am going to divide by 9 on all sides here. And that being the case, if I am dividing that by 9, let's see, plugging this in real quick. On the left side here, I'm just going to have negative quantity x minus 3 squared over 9 plus y minus 2 quantity squared over 36 is equal to 1. It means that my center is going to be at, let's see, 3, 2. It means that, so let me put my center in. So the next thing that we need to do is we're going to, well, let's start graphing. So we're going to go over 3 and up 2. So 1, 2, 3, up 2. So there's my center. In the x direction, I'm going to go over 1, 2, 3 and to the left 3. In the y direction, I'm going to go up 6 and down 6. Because this is a hyperbola, and I know that because of the negative sign here, I'm actually going to make a box around my points like this. Then I'm going to put in my asymptotes, and those are going to go from corner to corner, corner to corner, okay? And then what's going to happen is I need to look at the graph and say, well, which one is negative? Well, since my x is negative, that means this became my vertice, and I'm going to follow the axis up, follow the asymptotes up, and then my vertice here, follow the asymptotes down. You are responsible for knowing this point, your focal points, your asymptotes. Let's get those done. So we have the asymptotes are going to be y equals plus or minus the square root of 36 over 9 x. But because my center has shifted from 0, 0, that means this is going to shift also. Because this is x and y, So this is going to be, let's see here, y minus 2 equals plus or minus 6 over 3. Oh, that's 2. So plus or minus 2 times the quantity x minus 3. And remember, that's a line. These are my asymptote equations. That means that I could have gone up 6 over 3, or just doing baby steps, up 2 over 1, up 2 over 1, up 2 over 1, till I got to the same place had I gone up 6 over 3. I also need to know where my focal points are. And my focal points are going to be, I'm going to use this equation to find the foci. C squared equals a squared plus b squared. So C is equal to the square root of a squared plus b squared. So what, 36 plus 9? So that's 45. So C equals plus or minus the square root of 45. Square root of 45 is 9 times 5. So that's going to be plus or minus the square root of 3 root 5. Because these points are on, they're always going to be here and they're on my y-axis, I'm going to add them to the center at 2. So we're going to go parentheses 3, comma, 2 plus or minus 3 root 5. Oh, and just to make sure you understand, the transverse axis is this axis right here. So the transverse axis, this is A. So this is going to be 2A. Transverse axis, 2A. Whereas the conjugate axis is the smaller one, and that's your B, little b's. This conic right here is a hyperbola also. We know that because we're just looking at the first two terms in our squared. So I'm going to group my terms. So I've got negative x squared minus 18x. I've got a y squared, so plus 4y squared minus 8y equals 41. And so what I'm going to do is I'm going to factor out these values, because remember, to complete the square, not only do you need an x squared term and an x, or a y squared term and a y, but your x squared term coefficient has to be 1. So we're going to temporarily factor out this negative 9. So that's going to be x squared plus 2x. Half of 2 is 1. 1 squared is 1 again here. Plus 4 times y squared minus 2y. Half of 2 is 1. 1 squared is 1. Is equal to 41 minus 9 plus 4. So we have negative 9 times the quantity x plus 1, quantity squared, plus 4 times the quantity y minus 1, quantity squared, is equal to, now 41 plus 4 is 45. 45 minus 9 is 36. So this equals 36. So now what I'm going to do is I'm going to divide out this 36, because remember, that has to be 1 if it's in standard form. So divide out the 36 all the way through. We get negative quantity x plus 1 all over 4 plus y minus 1 quantity squared over 9 is equal to 1. So this is the equation of my ellipse, or excuse me, of my hyperbola in standard form. And again, it's a hyperbola because this minus sign right here. My center of my hyperbola is going to be x, negative 1, comma, positive 1. So we're going to go negative 1, positive 1, there it is. In the x direction, I'm going to go 2. In the y direction, I'm going 3. And remember, it is a hyperbola. So that means that we're going to make this into a box here. We're going to make this go corner. Asymptotes are going to go corner to corner. It also means that, let's see, because my x squared term is negative, that means that, again, my hyperbola goes up like that. So it's going to go up, follow the asymptotes, up, follow the asymptotes, and down like that. Again, transverse axis, this is a vertice focal points are going to be c squared equals 9 plus 4, so that's 13. C equals plus or minus the square root of 13. My center is at negative 1, so my focal points, which are going to be in here somewhere, those values here for both of them are going to be, let's see here, it's on the y-axis, negative 1, comma, 1 plus or minus the square root of 13. Did I do my asymptotes? No. Okay, one more thing. Writing the asymptotes. So the equation of the asymptotes, starting off with as if it was at the center, plus or minus, it'll be the square root of 9 over 4, so 3/2 x. But because my center is not at 0, 0, I'm going to go y. This goes with y. This goes with x. So it's going to be y minus 1 equals plus or minus 3/2 times the quantity x plus 1. And remember, those are not squared because they're lines. These are asymptotes. Asymptotes are just lines. Okay, determine the equation of a parabola that has a focus at 0, 2. So let me draw my graph. So this is going to be up here at 0, 2. All right. Focus point is here. Put an F there to remind you of what it is. And a vertex at 0, -4. 1, 2, 3, 4. So there's my vertex. That tells me that my graph does this, right? It also tells me that the distance from my focus to my vertex, okay, is, what is it? -4 here, 2 here, 6. So 6 is equal to P. So what that means is that because it's a happy graph, we're going to go y minus k equals a times x minus h quantity squared. So my vertex is right here at 0, -4. So it's going to be y plus 4 equals a times the quantity x minus 0 quantity squared. Now a, this value here is 1 over 4p, right? Well, p is 6. So 1 over 4 times 6 is 24. So we're going to go y plus 4 equals 1 over 24 times that, which I'm just going to leave it as x squared. And that's a 4. Okay, and lastly, for those of you who don't write the equation this way, you can write it like this. 24 times y plus 4 is equal to x squared. Given this equation, what is it? Well, this is a, let's see here, x squared, y squared, they're both positive. All I'm looking at are these. It's an ellipse. Okay, now I need to group my values. So we're going to go 2x squared plus 8x. We have plus y squared minus 16y is equal to -52. Always move that over to the other side. So then it means that we're going to complete the square twice. So we're going to take out a 2 first. So x squared plus 4x, half of 4 is 2, 2 squared is 4, plus y squared minus 16y, half of 16 is 8, 8 squared is 64, equals -52. Now remember, I added 2 times 4, which is 8, and I added 64. So 64 plus 8 is 72, and we have -52 plus 72 is 20. And that means that this value over on the right is now 20. So we're going to have 2 times the quantity x plus 2 quantity squared plus y minus 8 quantity squared equals 20. To put this in standard form, this value needs to be 1. So we're going to divide everything by 20, 20, 20. So we're going to have x plus 2 quantity squared over 10 plus y minus 8 quantity squared over 20 is equal to 1. So this is the equation of my graph, and it's an ellipse, remember, positive, positive. It means that the center is going to be at -2, 8. So -2 up 8. Let me move this down a little bit. Okay, so if it's at -2, 8, that means that over 2 up 8, there's my center. It means in the x direction, I'm going to go the square root of that value. Remember, this is my a squared. This is my b squared, because a squared is always, a is greater than b. So square root of 20 in the y direction, square root of 20 is like 4 point something. So we'll say it's here. In the same as here. In the x direction, I'm going to go the square root of 10, which is 3 point something. And because it's an ellipse, I am going to connect the points like this. Okay. I am going to have focal points. My foci are going to be at c squared equals a squared minus b squared. So c equals this plus or minus the square root of 20 minus 10, which is 10, square root of 10. So c equals plus or minus the square root of 10. So that means up root 10, down root 10, and those are my focal points. So where are those? So you're going to have to tell me where those are. Those are going to be on the y-axis again. My center was at -2, 8. So because it's a y-axis, my focal points are going to be -2, 8, plus or minus, that goes for both of them, square root of 10. And that's my foci. Those are my foci. Just a note, remember, my major axis is always the larger axis, and my minor axis is the small one. And to find that, because all the other ones we've done have been like perfect squares. So if this is a squared, then a is equal to the square root of 20, right? So if I wanted to know the length of my major axis, it would be a is equal to 2, it would be 2a, right? So it'd be 2 root 20. But you can simplify that. So you know root 20 is root 4 times root 5, which is 2 root 5. So times 2, so that's going to be 4 root 5. And so that would be the length of the major axis. And then the length of the minor axis would just be 2 times root 10. So the next question says, find the equation for a hyperbola. And this hyperbola has vertices here and here. And it didn't tell us where very much, but it did tell me that my vertices were there, and therefore giving me my vertices, that's giving me my my major transverse axis. So we're going to go over 8 and up 14. So again, I need to move this down a little bit. Over 8 and up 14. So there's 8. Here's 8, and up 14 is up here. We'll say let's move this up. So there's 14, and then the other point is 8 negative 10. So that's down here at 8 negative 10. So what that's telling me is that halfway in between there is going to be my center. Well, if this is negative 10 and that's 14, that's 24 total, which means that 12. So up 2 more, that's where my center is. And so that's going to be 8, 2. So this is a hyperbola. It tells me that this is my y-axis. So basically what this is saying, because it gave me my vertices, this is what it's telling me, this, all right? That my hyperbola is doing this thing like that, all right? Now, so therefore, that tells me that my y-coordinate is positive. So we're going to go y minus 2 quantity squared over something, and we're going to go x minus 8 quantity squared over something else. And I know that because this distance from here to here, right? What did we say that was, 12? That means under y is 144. My conjugate axis, remember that's the axis that just kind of goes across like that but doesn't connect anything. That's 6. So that means that I went 3 to the left and 3 to the right, which means underneath this is a 9. All right, so this is my equation of my hyperbola in standard form. Oh, so now we have find the intersection of the 2 equations. So that we're trying to solve the system. This is a non-linear equation, but however, we are using a line. This first equation here looks like it's a parabola. This equation is a line, and our job is to find the intersection of those. This graph right here, I'm going to rewrite that. That's going to be 2y, or that equation, plus 10 equals x squared, 2 times the quantity y plus 5 equals x squared. So y plus 5 is equal to 1/2 x squared, or x minus 0. Yeah, I like that better. 1/2 quantity x minus 0. And what that's telling me is that this is a parabola that has a vertex at 0, -5. So that means that at 0, -5, that's a parabola. Or I have a vertex there. Remember that 1/2 is equal to 1 over 4p. Cross multiply, 4p equals 2. P equals 2/4, or 1/2. So if the length of my either lattice rectum, or you call it the focal width, meaning that's the width of the parabola, is 4p. Then, and p is a half, so 4 times a half is 2. So what that's telling me is that my parabola is like super skinny. Means it's that distance is going to be, there's my focus point. It's going to be like 1 here, 1 here. So it looks like this. Okay, that's what my parabola looks like. Now, none of that is what I'm looking for. I am not looking, that just gives me an approximation for what my graph might look like. This equation here is a line. And so that looks like it's negative y is equal to negative 3x plus 9. Y equals 3x minus 9. That means that my graph is starting down here at negative 9. It's going to go up 3 over 1, up 3 over 1. So this graph looks like it's going like this. Now, it's really hard for me to see what my graph looks like because I'm not sure if maybe I made my parabola too thin. Did I? Did I not? I don't know. We're going to have to find out. Because what if my parabola looked like this, just a little bit wider? What if it looked like that? So what I need to do is I need to find my intersection points. And so maybe the graph is completely wrong. And so that's how you find it, is by solving algebraically your answer. So we're going to take these two equations. I've got y equals, where's my equation? I've got y is equal to 3x minus 9. I'm going to take what y equals, and I'm going to plug that in for y. So see this y right here? That's where it's going to go. So we're going to have x squared equals 2 times y, which is 3x minus 9, add 10. So we have x squared equals 6x minus 18 plus 10. So x squared minus 6x, and this right here is negative 8. So plus 8, if I move it to the other side, equals 0. So I have x minus 4, and I have x minus 2 equals 0. So I have x equals 4, and I have x equals 2. So what this tells me is that I'm actually going to have at least 2 intersection points. Y is equal to 3x times 9. 3 times 4 minus 9. 12 minus 9, which is 3. So when I plugged in 4 for x, I got 3. Well, that tells me that this is 4, 3. My other intersection point is going to happen with x equal to 2. Now I got to plug that in. So if I plug in 2 here, 3 times 2 is 6. 6 minus 9 is negative 3. So at 2, negative 3, I have another intersection point. And so that's how you find your intersection points, by graphing and proving it algebraically. This equation right here, x squared, solve the system. Again, this looks like these are both parabolas. Okay, these are parabolas. This is a parabola for sure that goes up at 4. This is a parabola that starts at 3. I'm not sure these even intersect. Let's see. I'm going to speak. Do you guys see this? We're going to solve this like this. We're going to solve this by the y's equal to each other, setting the y's equal to each other. So 2x squared plus 3x plus 4 is equal to x squared plus 2x, add 3. Subtract 1x squared, it's x squared. I'm going to move this 2 over. I get plus x. 3 over plus 1 is 0. Oh, this right here is imaginary. We're going to have imaginary solutions, which tells me that there's going to be no solution. It means that there's no intersection points, meaning my parabola might look something like this, and then it might also look something like this. So I'm actually not going to have any intersection points for these two graphs. What does this say? Oh, the lines, oops, let me figure this out. The lines, it says here, the lines do not intersect, or the parabolas do not, there's no intersection, therefore there's no solution. So solve the following system. So let's see, this 4x squared plus y squared, that's an ellipse. X squared plus y squared, that's a circle. So what we have is this is an ellipse, and this is a circle. Let's see what we get when we graph these. For this one, let's see. For a circle, center is at 0, 0. If my center is at 0, 0, in the x direction, I'm going to go the square root of 10, which is 3 point something. So 1, 2, 3 point something. 1, 2, 3 point something. And then that's all the way around. So 3 point something, 3 point something. So this looks like the second equation. Okay, this one right here is an ellipse. So I need to fix that a little bit. So we've got 4x squared plus y squared equals 13. We're going to divide everything by 13. And what I end up getting is x squared over 13 divided by 4 plus y squared over 13 is equal to 1. You have to leave this as 13 over 4 because technically you can't have any value in front of the x squared term. So we're going to multiply by the reciprocal, which is the same thing as dividing. So we have 13 fourths. What's 13 fourths? 4, no, 3, yep, 12. So it goes in there 3 times, 3 and some change. Square root of 3 is like 1 point something. So we know that this one's going to be from the center over 1 to the left 1. Now, this is the square root of 13. Now, the square root of 13 is 3 point something. So it's going to be 3 and some change also. So not sure what this graph looks like. Does it go like this? I'm not sure if it goes through there or not. The way to find out is that I have to solve it algebraically. So what I have here is 4x squared plus y squared is 13. We have x squared plus y squared equals 10. Just so many people are so used to solving this system by elimination that I am just going to, not elimination, by substitution, meaning this, I could solve the second equation for x squared and get 10 minus y squared. And then, and then I would plug that in right there into into x squared right there. That would be fine. But I'm going to subtract these like this. So 4x squared minus 1x squared is 3x squared. Y minus y is gone. 13 minus 10 is 3. I get x squared equals 1. X equals plus or minus 1. You get 2 answers. Don't discount the fact that you have 2 answers. It means that I'm going to get 1 comma something and negative 1 comma something. Okay, now to find the other values, I need to plug 1 into the other equation. So go back up to the top. What do we plug? Pick 1. It doesn't matter which. I'm going to pick this one. X squared plus y squared equals 10. So 1 squared is 1 plus y squared equals 10. Subtract 1. Y squared equals 9. Square root both sides. I get y equals plus or minus 3. Which means that when I plugged in 1, I got positive 3, and when I plugged in 1, I got negative 3. It also means when I plug in negative 1, because see how this is squared, negative 1 quantity squared, I still get 1. And I'm going to get 3 again, and I'm going to get negative 3. So what that tells me is this, that over 1, up 3, left 1, up 3, down 1, 3, 3. That this is my parabola. And my ellipse, and therefore those are my intersection points. This one says solve the following system. This is a parabola, and this parabola, it looks like just goes up 1, 2, 3 here and goes up super happy like that. Okay, and this is a circle, and that circle has a center at 0, 0. So 3, 3, 3, 3. Well, this one looks pretty simple, actually. I probably should have started with this one. To me, it looks like my only intersection point is 0, 3, but I'm going to check. Let's plug in this value for y right here, and then that's going to go in there. So we have x squared plus y, which is this value, x squared plus 3, quantity squared equals 9. This is substitution. I get x squared plus, now I'm going to substitute. This becomes, that is x squared plus 3 times x, that's not right. Hold on. Is that right? X squared plus 3. Oh, it is. oh, I don't want to do this. X plus 3, because that becomes, now I have x to the 4th power. 3x squared and 3x squared makes plus 6x squared. And then I have, plus 9 minus 9 is 0. So these are going to cancel out. That's not awful. I get x squared plus 6 plus 1 is what? 7x squared is equal, excuse me, I'm all off topic here. Where am I at? X to the 4th, let me fix this. Ding, ding, ding. X to the 4th, that's this one, plus 6 plus 1 is 7. X squared is equal to 0. So I'm going to factor out an x squared. I'm going to get x squared plus 7 is equal to 0. I'm going to get 0. I'm going to get this, split this up. I get x squared equals 0, and I get x squared plus 7 equals 0, which means x squared equals negative 7. That is imaginary. This one's not going to work. No solution for that side. But x squared equals 7, or excuse me, x squared equals 0, so x equals 0. Take this value, that's the only one that you have that works, plug it back into the other equation. So here we go. Y equals 0 squared. I'm plugging it into this. Add 3, so y is equal to 3. So when I plugged in 0, I got 3. So there's my intersection point. Awesome. So, oh, we're done. Basically, what this is telling me is that that concludes our review for Last Minute Lucy conic section. I hope that helped you prepare for your test that you're going to be taking soon. And thanks for watching. I appreciate it.